Hello Patriots, this is the last lesson in topic 20 that we are going to discuss, and this lesson is over misleading graphs. You do not need to take notes on this if you do not want to. I just want you to listen and think about what's being said. The big idea is that the scale of a graph influences the patterns that can be observed in the data and the interpretation of those patterns. That's a lot of words. First of all, when we go up to this scale, remember we talked about this scale in our other graphs that we made, and we talked about intervals, what the intervals were, but what are the numbers at the sides or even at the bottom depending on the type of bar graph. If you look to the right over here, we talk about how can you tell if a graph is misleading. They give you an example of a graph. It's basketball team's high scorer, and they show Juan and they show Vinny. And on the left side, they have their scale, and it's points per game, and it starts at the bottom with 10, 12, 14, 16, goes all the way up to 24. Here it shows that Juan and Vinny are two high scorers on the basketball team. What impression does the graph give, and why is it misleading? So I'm going to pause for you to take a good look at that graph and think about those questions. Okay, what you should have noticed that just by looking that it looks like Juan has twice as many or 2 times as many points per game than Vinny has, because our bar, if you look here, goes up 1, 2, 3 lines, and Vinny's goes up 3 more from that, 1, 2, 3, so that's twice as many. But when you look at the actual scale on the side, Vinny has 16 points and Juan has 22, and 22 is not twice as many as 16. We know from our math that 32 is twice as many as 16. So that's a misleading graph. If you look at the next one, and there's 2 of the same graph, I don't know why I did that. That was a mistake by Miss Weaver. Here is what the graph looks like with a scale that starts at 0. So here, if we start at 0 on our scale and we go up to 24, we show Juan here at 22 and Vinny at 16. Now, on this graph, you could see visually that Vinny doesn't have twice as many, so this one right here would be a more accurate graph, whereas this top one is misleading. I also want you to understand that a misleading graph is not always intended to mislead people. Sometimes people make mistakes, and they may not realize that the choice of their scale affects the impression given by the data. On the more accurate graph here, you can still clearly see that Juan is the team's higher scorer, but not by twice as much. It's less than double. Okay, on this second example, again, you do not need to draw this yet in your 2-column notes. We have a bar graph of longest well lengths right here. And they show the fin well and the blue well. And on our graph, it starts at 75, 100, 125, 150. And if I think of my intervals, if I count from 75 to 100 or from 100 to 125, I know that my interval is 25. So they want to know about how long is the blue well. Well, if we have 100 here and 125 here, I would say a good guess for that well is about 110 feet. And I got that because, again, here's blue well, there's 100, there's 125, and so halfway is around 112, and so I would say that's about 110 feet. How long is the fin well? Well, here's the fin well. If I draw my line down, there's 75, there's 100. I would say that's close to about 90 feet. The question is, why is this graph misleading? I am going to pause so you can think about and formulate an answer. Okay, let's take a look. I want to remind you, students, that the bar graph scale is one of the first things to check when deciding if a graph is accurate, and it provides a useful comparison of the two or more data elements. So if we look at the graph scale right down here, oops, doesn't want to work. That should be a good indicator of why this graph is misleading. So the purpose of a bar graph is it's a way to show data accurately and clearly just by looking at it. If you look at this scale, here it starts at 75, and if you look at the bars, it looks that blue well is about twice as long as the fin well. But in reality, the blue well is 110 feet, the fin well is 90 feet, and 110 is not twice as much as 90. For that to be twice as much, the blue well would have to be 180 feet. And we could see that the blue well is not 180 feet. For this graph, I think that you should, in your head, you should be thinking that a different scale should be used, and perhaps starting at a different number than 75, or using an interval of 25. Okay, we're going to begin our 2-column notes, so your journal needs to be open. And this is going to be for topic 20, lesson 5. We're going to have a question on the left side of our 2-column notes, and I guess it's a question. Make or create a chart or graph using the following data. And we are going to do t-shirts sold. And so for 2003, we are going to represent with tally marks t-shirts sold as 10. For 2004, we're going to have 20 t-shirts sold. For 2005, we're going to represent t-shirts sold by 25 tally marks. And for 2006, we'll have 35. And you can tell by writing all those tally marks that when your data gets to be up in numbers, tally marks is probably not the way we want to represent our data. It takes too long, too many marks. I'll pause so you can get that data down on the left side of your 2-column notes. Okay, on the right side, I want us to draw a graph of the data on the left side. So we're going to draw our line. Oh, that's too long. Let me fix that a little bit. Let's go here. And let's go over here. And let's start at 0, and we'll do 20, 40, 60, 80, 100. This is the number of t-shirts. Okay, and here we're going to write 2003, 2004, 2005, 2006, and this is the years. Okay, and the title of our graph is T-shirts sold. If we look at 2003 data, 10 t-shirts were sold, so we don't have 10 on here. We start at 0. Our interval for this graph is an interval of 20. So we have 10. We're going to come over and draw our bar graph. For 2004, it's 5, 10, 15, 20. So we will come up to 20. For 2005, it's 5, 10, 15, 20, 25. So we need to go 20. And middle is 30, so 25 is about right here. And then for 2006, our data shows 5, 10, 15, 20, 25, 30, 35. 20, 40, in the middle will be 30, a little over halfway would be 35. I'm going to stop and pause so you can graph your data. Okay, if you look right away at our bar graph, it looks in 2004 that there were just a few more shirts sold than 2003, where our actual data 2004 sold twice as many, 2 times as many shirts as 2003. So right there you can see where this is a misleading graph. Let's draw another graph. And here we have 2003, 2004, 2005, and 2006. And instead of having an interval of 20 on our scale, let's see, 5, 10, 15, 20, 25, 30, 35, 40. And I'm going to pause there so you can make your graph. Okay, let's draw our bar graph. For 2003, we need to go to 10. So that is right here. For 2004, it's 20. So we are going to go up to this line. And right away you can see that the graph looks a little less misleading because this amount, this bar right here, is about twice as big as the first one. The next one should be 25, so let's go over 25. And the last year, 2006, is 35, so we want to go up to 35. So immediately you could see the data is shown more accurately or less misleading. I'll pause there so you can graph your bar graph. Okay, this is our last example. You do not need to draw this in your 2-column notes, but I want you to be able to explain it in class when I ask questions. Let's look at those 2 graphs that are side by side. In the first graph, t-shirts sold for a basketball fundraiser, and you see the years 2003, 2004, 2005, 2006. And our scale starts at 0, but it goes, the next number is 20, 40, 60, 80, 100, and so on. So on the first graph, our interval is 20. In our second graph, the scale starts at 0, but the next number is 5, and then 10 and 15. So our interval is different. Our interval is 5. So if you look at both graphs and you wanted to just be able to look at it, which one do you think might be misleading? I'm going to pause for you to think about it. Okay, if you look at both graphs, the scale in the second graph only goes to 35. So here's our scale, and it only goes to 35. The scale in the first graph goes to 140. What does the smaller scale show? The smaller scale distorts the changes and makes them appear greater. Which graph do you think gives the more accurate impression of the data? If you look at the smaller scale, it's easier to see that the increase was greatest in 2004. For example, let's look here at our smaller scale. From here to here was a big jump. From here to here, it went up, but not as much. And from here to here, cells went up, but not as much. So right away on this second graph here, you could see by the smaller scale that the greatest increase in cells was from 2003 to 2004. And that's a great way to look at a bar graph and be able to interpret the data. That's the last lesson in this topic. We will do work and do more problem solving in class. Have a great day.